Dear students, so this session we will discuss about the calculations part. So we have discussed in the last sections like the winding technology, particularly we have seen drum winding and precision winding machines. Okay, so the particularly today's session we will discuss about the what are the calculations part and how we can calculate the production. Okay, so specific to the production of winding machine. So as we have seen that the winding machine is having 60 number of drums. Okay, so winding drums we have around 60 drums in drum winding machine. Okay, so individually like in each and every drum what is the production and overall what is the machine production. Okay, so we will see in this session. Okay, so let us start the calculations part. So before going to the calculations part, we should know some of the conversion factors in the for textile calculations. So specifically like conversion, simple conversions like how we are going to convert the yards into the meters. Okay, so the length terms. Okay, so how we can convert the yards into meters, inches into meters, or inches into yards. Okay, and as well as by considering the count. Okay, by considering the count formulas like yard numbering systems, we have direct numbering systems and indirect numbering systems. Okay, so already you have studied what are the yarn numbering systems are. Okay, so what is the yarn numbering systems? We have two different types of yarn numbering systems. One is called as like direct numbering system, and the second one is called as the indirect numbering system. So direct numbering systems we are going to see specifically. So the most of the people we are going to use the text terms and the denier terms. Okay, text and the denier. So the yarn numbering, that too particularly direct numbering system, we are using text and the denier. Okay, and there are others also. So most probably or most of the times for particularly like man-made yarns, we are going to use the terms that is yarn numbering system, that too direct yarn numbering systems. So text and the denier. And in case of indirect yarn numbering systems, we have many. So out of these, because I am not going to cover what are the different types of yarn numbering systems. Okay, so as you already studied, I am recalling that. Okay, so in the indirect system, particularly spun yarns, cotton spun yarns or PC blended spun yarns, we are going to use the count, that is NE, English count. Okay, so English count we are using. So we will see first what are the different or what are the various conversion factors specifically we are using in the textile industry or textile applications. Okay, then we will go for the simple and small calculations part of count. Okay, how we can evaluate or how we can calculate the count. Okay, and as well as if the count and the weight of the yarn is given, how we can calculate the length of the yarn. Okay, and if the length and the count is given, how we can calculate the weight of the yarn. Okay, so like simple things we'll discuss one by one. Okay, now you can see here I have given a simple examples or simple conversion factors. So you can see that 1 centimeter is equal to 10 mm. So you know that 1 centimeter is equal to 10 mm. Okay, and you can see that 1 inch is equal to 25.4 mm and that is equal to 2.54 centimeter. Okay, and 1 meter is equal to 39.37 inches and that is equal to 1.0936 yards. Okay, and the next conversion is yard to meters and the inches. So 1 yard is equal to 36 inches and 0.9144 meters. 1 yard is equal to 0.9144 meters. Okay, and 1 ounce is equal to 1 ounce is equal to 28.35 grams. Okay, and 1 pound is equal to 7,000 grains and 453.6 grams. Okay, and 1 gram is equal to 15.43 grains. 1 kilogram is equal to 2.2046 lbs. Okay, so these are the important parameters, or these are the very important conversion factors. So if you know, then only we can able to calculate the count calculations as well as the production calculations of the different machines which are involved, which are there in the weaving preparatory stage. Okay, particularly. So as well as in the weaving also we have some calculations to calculate the production of the weaving machines and all. Okay, so these are the conversion factors which are very important to calculate, or to know about, or to evaluate the particularly the count calculations as well as the production calculations of the particular machines. Okay, so these are the factors. We will see one by one what is exactly the how these are going to be used in the calculation of or application of the particular calculation part. Okay, now you can see here count NE is equal to, what is the formula? I have given a simple formula. What is count? Okay, so count is nothing but, count NE is nothing but number of, so length in hangs of 840 yards, length in hangs of 840 yards, weighing in 1 pound. Okay, so length in hangs of 840 yards, weighing in 1 pound is nothing but the count. This is the simple definition of count formula. This is the simple definition of count formula. Okay, so we will see that what is exactly this count and how we can going to calculate the count, okay, NE, by using the simple calculations or simple things. Okay, so here you can observe an example 1. So I have given that a lee of 120 yards of cotton yarn weighs 40 grains, and we are going to, so the calculation part, what we need to do is to calculate the count of yarn. Okay, we need to calculate the count of yarn. So what are the given parameters? So here, so the given that so what is there? Yarn length is given. Yarn length is given. Yarn length, that is 120 yards. And what is the count we have given? So we need to calculate the count. So the count need to be identified. Count NE need to identify. And the weight is given. Weight is given, that is 40 grains. 40 grains. Okay. Now we need to convert. So we will see that what is exactly the count formula. Count NE is equal to, count NE is equal to, now length in yards divided by 840 whole divided by 453 point whole divided by grams, that is weight, divided by 453.6. Okay, so as the count formula is given, length in hangs of 840 yards, weighing in 1 pound. So what is 1 pound? 1 pound is equal to 1 lb. 1 pound or 1 lb is equal to 453.6 grams. Okay, clear. So now by using this formula, we are going to calculate the count. So now, so this formula I have simplified. I am going to simplify this formula. So you can see that, you can see here the count NE is equal to, so length nothing but length of yarn. So length of yarn in yards, length of yarn in yards divided by 840 multiplied by 453.6 divided by weight in grams. Okay, weight in grams. So this is the simple formula. So now what is the question we have? So the example 1, we have given that, so the yarn length in 120 yards, weighing in 40 grains. So it is given in grains. Now what we have to do is, we have to convert these grains into grams, because in the formula it is in the grams. So now 1 gram is equal to, we need to know that, we need to see that 1 gram is equal to how many grains. Okay, so as I told earlier, 1 lb, that is 1 pound, is equal to 7,000 grains. And how many grams it is? It is 453.6 grams. Now, so to calculate, 1 gram is equal to how many grains? 1 gram is equal to 7,000 divided by 453.6. So if you calculate, it, 7,000 divided by 453.6, it is comes around 15.43 grams. Okay, so 1 gram is equal to this many grains. Now what the formula, what the calculation part we have given, the given that is 40 grains are there. We need to convert these grains into grams. So now what is 40 grains means how many grams? Okay, 40 grains nothing but how many grams? Okay, so you can calculate that 40 divided by 15.43. Okay, so it will come around, so if you calculate it, 40 divided by 15.43, it is around 2.59 grams. Okay, now we have converted the grains into grams. Okay, grains to grams. Now we know that the yarn length, which is 120 yards, and how many grams, which is weighing in 2.59 grams. Okay, so we will calculate now what is exactly the count of the given after converting the grains into grams. So what is given is, that is yarn length is given 120 yards, and weight of the given yarn is 2.59 grams. Now again I am writing count NE formula, length in yards upon 840 multiplied by 453.6 divided by weight in grams. Now length what is given? 120 divided by 840 multiplied by 453.6, and weight is given or calculated for 2.59. Okay, so from this we can calculate the count. So the calculated count is 25.01, that is equal to 25 Ne. Okay, so this is the calculation how we can calculate the count of yarn if the weight and length is given. Okay, so we will see one more example how we can calculate the length. For example, in this case particularly we have calculated the count Ne. For example, if the count is given and weight is given, how we can calculate length? Okay, or for example, if the length and Ne count is given, how we can calculate the weight of the yarn? We will see one more example so that you can understand very easily how we can use this formula to calculate the weight, length and count of yarn. Okay, particularly. Now we will discuss a small example problem how we can calculate the weight of yarn if the count and length of yarn is given. Okay, we will calculate weight of the yarn which is given, particularly if the yarn count is specified and the length is specified. Okay, so let us see that. Okay, so directly I am writing that example 2 we are discussing. So given that now in this yarn length I have given that, say for example 2000 meters yarn length is there, 2000 meters, and yarn count that is Ne, say for example it is 50s Ne. Okay, for example it is 50s Ne. Now what is the calculate yarn, weight of yarn, calculate weight. Okay, so we need to calculate the weight. Now again I am writing the formula of count. Okay, so that again it can be reminded. Okay, so count Ne is equal to length in yards and 840 multiplied by 453.6 divided by weight in grams. Okay, now what we need to find out is, we need to find out, now here given is 2000 meters, so it is in the meters. Now we need to convert these meters into yards, so we need to convert meters into yards. So now what is yards? 1, how we can convert it is, so meters to yards we can convert by multiplying with 1.0936. Okay, so 1 meter is equal to 1.0936 yards. Okay, now what we need to convert is, we need to convert into yard, meters to yards. Now how many meters are given? 2000 meters are given. We need to convert into yards. Okay, so 2000 divided by 1 multiplied by 1.0936, that is equal to okay. So we can convert meters into yards. So here I have converted 2000 meters into the number of yards. Okay. So now the yards are there and the weight in grams. So weight in grams you need to find out. Okay. And the count is given. Count is given. Length is given. Weight we need to find out. So what is going to happen now? Now what is the formula? So weight in grams is equal to, now length in yards upon 840 multiplied by 453.6 divided by count NE. Just it was change the place from NE to weight. So now what is the length? Length is 2187.2 divided by 840 multiplied by 453.6 divided by count, that is given is 50s NE. Now, so if it is calculated, it is coming around 23.63 grams. Okay, so this many grams of weight. So this is how we can calculate if the yarn length and count is given, and we are going to calculate the weight, particularly weight in grams we are calculating. Okay, so this is the simple calculation how we can calculate the count and the yarn length and the weight of the yarn from the two components, any two. If we know that the count we know and length we know, we can find out the weight. For example, if count is unknown, length and weight is known, we can find out the count. If count and weight is known, we can find out the length. So this is a simple cross multiplication where we are going to calculate or evaluate the count, length as well as the weight of the yarns. Okay, so let us move into the next thing, that is winding calculations. So we will see that and how we can calculate the production of the winding machine. Particularly we will see one by one. Okay, till now we have discussed about the count formula. By using the count formula, how we can calculate the weight of yarn, count of yarn as well as the length of yarn. Okay, if any two parameters are given, we can find out any one by using the count formula. Okay, so particularly from here we are going to discuss about the winding calculations, winding machine production calculations. You can see that to calculate the production of a cone winding machine with the following parameters. There are given parameters. So you can see that the drum speed, which is given 2000 revolutions per minute, 2000 revolutions per minute, and drum dia. So we are calculating particularly for the winding machine, drum winding machine. Okay, so here they are given that the drum diameter 3 inches and number of drums in the machine is 60 and yarn count, running yarn count is 60 NE, and efficiency of the machine, so including like so whatever the stoppages, ideal times are there, that was removed, and exactly what is the time which is running the machine. So for example, out of 8 hours, how many hours working time? So because there is an ideal time also, so because of the stoppages, because of the mechanical failures, or because of the so many factors, so there are chances of idle time. Okay, so by all including, by considering all those things, we have seen that now the given that is winding efficiency, so that is winding machine efficiency 85%, and a shift of 8 hours generally will work. Okay, so these are the parameters which are given. Now by using these parameters, we are going to calculate the production, particularly the production of a winding machine, so in the kgs. Okay, we will see that how we are going to calculate the production. Okay, so before going to the calculation part, we will see that again we will remind you that, so what is the conversion factors. Okay, so simple conversion factors we have already discussed, so let us discuss again. So 1 meter is equal to 39.37 inches, 1 yard is equal to 36 inches. Okay, and 1 meter is equal to 1.0936 yards, 1 yard is equal to 0.9144 meters. Okay, and so these are the things where we are going to convert from inches to meters, meters to yards, inches to yards, like that. Okay, so let us see that the problem. Okay, example problem. So how we can calculate the production of the winding machine is. Okay, so I'm writing the formula of production of a winding machine. So you can see here, production in kgs. I'm giving the formula for kgs conversion. So kgs per okay, a shift of 8 hours. Okay, so this is we are going to calculate. So for this, and the given whatever the drum speed and the drum diameter are given, we are going to calculate one by one. Okay, so we are going to calculate first surface speed of the drum. Now what is the formula for surface speed? So that is pi dn. So pi is nothing but 3.1428, diameter is given in 3 inches, and speed is 2000 rpm, revolutions per 1 minute, rpm. Okay, so 2000 rpm, it is 2000 rpm. So we can calculate the surface speed by using this formula. Okay, so this is in, after calculating 3.1428 into 2 into 2000 into 3 inches, we are going to get 18,856.8 inches per minute. Okay, inches per minute, it is running, the drum is running inches per 1 minute. So this is how we can calculate the surface speed of the drum. So now whatever the formula I am going to give you, so which is consisting of the surface speed. Okay, so to calculate the surface speed I have given that. Okay, now production in kgs per shift of 8 hours. Okay, so I am going to give you that speed, that is drum speed in revolutions per minute. Okay. So now to calculate the surface speed, what I have told, what is the drum diameter. So that too dia in inches. Okay. And for calculating the surface speed, 3.1428 is required, pi. Okay. So now this is the surface speed. What is the output? This is inches per 1 minute. Inches per 1 minute. Now inches per 1 minute, I am going to convert inches per 1 minute into yards per minute by divided by 36. As I told earlier, what is 36? 36 denotes 1 yard is equal to 36 inches. Okay. So by using this, we are converted inches to yards. Okay. Now yards, yarn length, that is yarn length in yards is came. Okay. So now in 1 minute, we are converting into per 1 hour. Okay. Per 1 hour, I have converted. So from 1 hour to I am converting into per 8 hours of time. Okay. Per 8 hours of time. And what is the efficiency? 85% efficiency. Okay. Now after converting yards, so we are going to convert by subtracting with 840, we are going to convert yards to hands. So hands we are converting into lbs, that is pounds, by subtracting with count ne. Okay. So up to here we got in particularly in lbs. Okay, pounds. So after lbs, 2.2046, that is nothing but 1 kg, 1 kilogram is equal to 2.2046 lbs. So we have converted into lbs to kgs. Okay. And this 85 percentage is the right. So for the percentage, 85 divided by 100. Okay. Now this is the production calculation for winding drum per 1 drum. Okay. Per 1 drum it is calculated. Now to calculate per 60 drums, whatever the answer or whatever the production is came, multiplied by 60, you will get the total machine production. So that is, here you can put number of drums. Okay, number of drums, so that you can calculate the production, right? So by using this formula, we are going to calculate the production of a given winding machine. Okay. So we need to substitute whatever the given is. So to calculate the production, so speed in RPM, that is 2000 multiplied by drum diameter in 3 inches, 3.1428 multiplied by 60 into 8 time, this is time, 60 into 8 is the time, 85 is the efficiency, 60 number of drums is given. And you can see that we are converted inches to yards. Yards we are converted into hands by subtracting with 840. Hands we are converted into lbs by ne, and lbs we are converting into kgs. Okay, so this is the total conversion. So the answer is 115.41 kgs per shift of 8 hours with efficiency of 85%. per 60 drums. Okay, so the count is 60 here. Okay, so this is how we are going to calculate the production of a winding machine. Okay, this is simple. So you need to understand how we have converted from one part to the other. Okay, one parameter to other parameter. So length to length, length to weight. Okay, so you can see that the speed in RPM. Okay, so we have converted this, we have calculated the surface speed of the winding drum in inches per minute. So inches we have converted into yards per minute. Okay, so inches per minute we have converted into yards per minute. Okay, so like we have calculated that the surface speed of drum, that is equal to pi d n. Okay, if diameter is d nothing but diameter in inches, if it is in inches. Okay, and n, that is speed, RPM, revolutions per minute. So what will happen? Inches per minute it will come. Okay, inches per minute will come. So now inches we have converted into yards by subtracting with 36.36. Okay, so this is the simple calculation how we can evaluate or how we can calculate the production of a winding machine. Okay, so next we will see that one more problem in winding machine. Okay, how we can calculate the production. Okay, so particularly if you observe here, so this production is 115.41 kgs per shift. So per shift of 8 hours with 85% efficiency. Okay, so if you want to calculate per 1 drum, so simple, without 60 you can subtract, or simply like so 115.41 you can divide it by 60, you will get the per drum what is the how many kgs of production is happening. So this is how we can calculate the production of a winding machine. Okay, so the next problem, that is in the winding machine. So you can see that the cone weight, particularly a cone weighing 1 pound, if a cone is to be produced in winding machine with a weight of 1 pound, what is the time required? Okay, so you can see that calculate the time required to produce a cone weighing 1 pound. Okay, what is the time required to? So what is the time required to produce a 1 pound of cone in winding machine? We will see how we can calculate. So you can see that the average speed of the drum is 2000 RPM, and cone, the count of yarn is 20 cne, and you can see that the drum diameter is 3 inches, and you can see here particularly the slippage also given. Slippage, 5% slippage is given. So nothing but we need to calculate at what is the actual speed of the drum. So because here what is given is, here the given is 2000 RPM is given, revolutions per minute, but there is no slippage is considered in the previous calculation. Now it is considered that there is a slippage in between the package to the drum, that is 5% is there. Okay, that is 5% slippage. So now we need to calculate, what is we need to calculate? We need to calculate actual speed of drum. Actual speed of the drum we need to calculate. So to calculate actual speed, What is the percentage of slippage is given? 5%. So 2000 RPM is the speed. Now 5% is given. Nothing but 5% is slippage. Now, so that what is the formula is 100 minus 5 divided by 100. Okay. So this is the given. Now, what is going to happen? 2000 multiplied by 95.95 divided by 100. So that is equal to 2000 multiplied by 0.95. So we will get 1900 RPM. So this is the actual speed of the drum after the consideration of the slippage. Okay. After considering the slippage. This is the thing. Now, after calculating, we are going to calculate that what is the production. Okay. Now we will recall what is the production formula. So from the production formula, how we can calculate the time required to produce 1 pound of yarn or 1 pound of cone weight. Okay. So we'll see that what is the production formula is. Okay. So the production formula is, so as we have studied, so production. So now what is the thing is here? Production in kgs we are seeing. If we want in lbs, only the small change, I'll tell you that. Okay. So just I am giving the normal formula to calculate how production in kgs we are going to calculate. Production in kgs. So that is equal to, so by considering the RPM only we are calculating speed in revolutions per minute into drum dia. So this is in inches. And 3.1428. Then this is the time. Okay, time nothing but I have given that 60 into 8. That is the time. 60 minutes, 8 hours. Okay, total how many minutes of time is there? Okay, time. So time. So here you can see that what is exactly the 75% of efficiency is given. Okay. So now what we have done is inches per minute we are converting into yards per minute. Yards we are converting into hands. Hands we are converting into count. That is lbs. Okay. So if you want to convert lbs to kgs, then we are using 2.2046. Okay. So 2.2046 we are using to convert from lbs into kgs. For example, if you don't want to convert, if you want only lbs, then in that case, what is the change? Change in the formula is now the production. So I am writing here, you can see the production in lbs. Okay, lbs. So we are calculating it into speed, that is in RPM, and drum dia, that is in inches, into 3.1428 multiplied by time multiplied by 75% efficiency. Okay, 36,840 count. Now what is our question is? Question is we need to calculate the what is the time required to produce cone of weighing 1 pound. What is the time? So we need to calculate the time. So now what is given is 1 lb is given, 1 lb is given, 1 lb is given already. Okay, so we need to calculate what is the time. So there is a simple calculation. You can see that 1 lb multiplied by 36 into 840 into count, whole divided by speed multiplied by dia, so that is drum dia 3.1428 into efficiency we are having, so I am keeping that 100 all places. Okay, so this is the formula, so that we can able to calculate here time. Okay, na? So this is how we can calculate. So now we will substitute whatever the given are. So you can see here time in minutes we are going to calculate here time. Okay, and 1, that is 1 pound we are producing, 36, 840 are the constants. Count is given 20 CNE. Count is given 20 CNE, and this is for efficiency. And speed is, now the speed is 2000 RPM is given. Okay, average speed. And by considering the slippage, it is came 1900. So now that is why I am going to take 1900. 3 inches is the drum dia. 3.1428 is the pi, efficiency is 75. So this is 75. So by calculating all, so it is came around 45 minutes of time. So total for 1 pound of yarn, if you want to produce 1 pound of yarn with a cone, so we required 45 minutes of time it is taking to produce 1 pound of yarn package. Okay, so this is the simple calculation how we can calculate time required to produce a cone weighing of 1 pound is. Okay, so it is, for example, I have given that 1 pound, so you can see that to produce 1 kg also you can calculate it. Okay, so these are the simple calculations in winding. We'll discuss more in the further session. Okay, so till then, thanks for listening. Bye.